Welcome to episode 43 of Fresh Thinking by Snowden Optiro. My name is Tarrant Elkington, General Manager for Snowden Optiro. Today is part 2 of a 2-part podcast on Inpit crushing and conveying, or IPCC. In the first podcast, we talked in general about the benefits and application of IPCC, and today we're going to get a little bit more into the technical detail. And with us to talk about this again is Phil Morris, who's an expert in IPCC. So Phil, thanks for joining us again.
Pleasure.
I thought we might start by talking a little bit about the types of IPCC systems that are available.
Okay, essentially we've got 4 different types of installations. So the first one is what we call a pit rim or an out of pit fixed installation. So essentially all we're going to do is bring a crusher from close to a plant to bringing it near to the edge of the pit, leaving the pit operation essentially unchanged, but then running conveyors from that crushing station either towards an ore plant or away towards a waste facility. Then we've got a fixed in-pit crusher, which I think we usually that's the one we call IPCC, and that's the type of installation that you would put in if you have a wall which doesn't move for a long period of time in a mine. So if a mine is expanding in one direction and we've found a location where everything stays put for a long period of time, that's a great opportunity to bring a crusher into the pit, but essentially it's fixed. And then as we move towards full mobility, we've got a system called a semi-mobile in-pit crushing option. And in that situation, we get mobile crushers, but they're only relocated every perhaps 2 to 3 years, or even maybe only once or twice in the life of a mine. But that system then becomes called a semi-mobile in-pit crushing system, SMIPCC. And lastly, a fully mobile system. Fully mobile system is where we go right from the shovel. The shovel loads some sort of breaker or feeding system and crusher that then runs directly onto mobile conveyors, in-pit conveyors, that then feed a series of fixed conveyors that get the material out of the pit. So as you move from the X-pit into fully mobile, obviously we're hoping to make further changes and improvements in reduction of operating costs, because the capital cost gets higher as we move through each of those sequences. So that's your 4 types.
And are there certain applications that suit particular selection of those systems?
Certainly. I mean, obviously, if the mine plan is complex and the interaction between your phases or stages is difficult, it makes it hard to bring in-pit crushing into the mine without a complete redesign. So the X-pit crushing option, the EPCC, it is usually the first port of call for an existing operation that we might be looking to try and modify downstream. As you move into the pit, there's certainly quite a few mines that have installed crushing stations at depth. And then the 2 ways that you get the material out from that crushing station is either through a dedicated conveyor ramp, and that limits your depth to about 150, 180 metres below surface, or you can put a tunnel in, an inclined tunnel out to the surface. So you're obviously only going to do that when you've got long life for that installation. Several copper mines that I can think of have done exactly that. The movement then to fully mobile might be most applicable perhaps in a coal mine with dipping stratum, where you're mining along strike and you've got the opportunity to keep mining in this direction and move material back behind yourself in a continuous operation. So you'd primarily be mining your overburden to give you access to the coal, and then you selectively mine the coal. So there's a quick example of each type.
Is it ever possible to completely get rid of the trucks out of your system with one of those fully mobile systems?
It is, although at the one operation in the world that's doing it at the moment, that Vale operate in Brazil, they've still had to use some trucking to do the pre-mine development, and later in the mine life it gets very complicated. It's extremely difficult to use fully mobile all of the time, except in linear coal mine operations, stripping when you're mining a long strike. So that's the only opportunity, but the only one that's in operation at the moment is in iron ore and the fully mobile scene.
And I guess, from doing your studies and a lot of them looking at existing operations and seeing if we can find savings for them, is there disadvantages to applying IPCC to retrofit to these operations, or is it better to have a blank sheet of paper at the start?
Clearly, the easiest way to have IPCC is actually to start with a clean sheet of paper, and if you know that you want to consider IPCC as an option when you're developing the mine, you need to do two types of feasibility study, one for a truck-driven based system, which will have some form of pit optimization that follows small blocks to the surface and almost inevitably ends up giving you curved walls. And you then need to run a mine plan which is specifically more suited towards an IPCC operation, where you may be trying to make your walls more linear and your interaction between your phases would be different. So it requires a different mine plan, which you could have the luxury of doing if you do it at the feasibility stage. But when you come to retrofit into an existing operation, it's much more difficult because the walls are already there, and whilst you're doing phase cutbacks, it's not always easy to modify them to be well suited towards IPCC. So there's no easy solution, and the mine planning for IPCC is more complicated than most people think. So that's the first challenge, and that's why X-Pit is so popular, because it requires the minimalist change to your mine plan.
All right, I just wanted to move to the evaluation of IPCC. So obviously, looking at the benefits of IPCC is a bit different than looking at a typical mining study. Can you tell us a little bit about how we evaluate the benefits of IPCC?
Sure. The first thing that we've got to do is have a look at, are we talking about retrofitting? I'm not sure, but the first thing we're going to do is have a look at the mine plan and the ore body shape, if you like, and see if it lends itself to a particular form of IPCC, and try and narrow down which type or style of IPCC is likely to give us the best solution. We might actually carry a couple of options into a study, but the first thing to do is to obviously have a solid look at the life of mine plan and review how best to move forward. In-pit crushing studies then generally go through a multi-stage process, as would any mining study, through a desktop analysis, which perhaps takes between a week and 10 days. A scoping study that might take 2 to 3 months, pre-feasibility and full feasibility. So in the early stages, what we discovered when we started doing a lot of these studies 20 years ago now was that a differential analysis was the quickest way to provide a realistic comparison. So what we say is anything that doesn't change, we don't need to know about. So if you're still loading with the same shovels, we only need to know the unit cost, because we may be loading subtly differently in one of our options. Drill and blast stays the same, so we don't use that. And then we work up what we call a differential mining cost with and without, from a base case to a case with IPCC. And then you accumulate the delta values either in favour of or against in-pit crushing, and produce a net present cost model differential. And that is a great way of making a decision to move into a more comprehensive study. Probably at the scoping level, you start to introduce an OEM, an original equipment manufacturer, into the equation and start to get some reasonable quotes for the capital cost of the equipment and the throughputs that could be expected through their equipment. So you become more focused in the study on trying to make it realistic. And obviously that then probably leads you into the pre-feasibility study, where you've got to bring the whole mine into the equation, including things like the power supply capital cost and the load on the entire system, all these peripheral matters. So it's at that point that you start to really involve the owner, and you need a team approach at that point. So that study is an order of magnitude cost up from a scoping level study. And then we separate ourselves from doing a differential analysis to doing a full cost model, which can be done perhaps in the client's cost modelling system, or we have an integration between them and whoever, ourselves doing the study, so that we can use their numbers to build the model. And then you're fully costed against their base case, life of mine, against the in-pit crushing. And obviously I think you're following the same procedure when you do a full definitive feasibility study, but you're lowering the plus and minus on the limits to the accuracy of your study. So you've got to go and dig into the nitty gritty a bit more. One of the only things I'd like to summarise with this is, in all the studies that we've done, the relative change, the desktop study gives you a great indication of whether in-pit crushing is going to work. And we can go all the way through these other studies, but generally the actual overall numbers don't vary that much. It's just an observation, it's not a statement, but it's good. What it means is that when you start to see good positive results for an IPCC analysis, it tends to stay positive. It doesn't flip over suddenly. So okay, that's good. Yeah.
That provides some comfort.
Yes. Yeah.
So and I guess I'll just throw one more at you. I guess what do you feel like, through your experience, is the greatest technical the technical challenge of IPCC?
The greatest technical challenge is trying to modify or integrate existing mine designs with the needs to optimise for in-pit crushing. It's a complex area that's not given enough thought process initially. All of our mine planning software in the industry at the moment, it works very well for truck shovel, and it gives you an enormous flexibility. That's what mines do. Mines always soak up the flexibility to allow the plant to keep operating in a perfectly level state. And so if anything goes wrong with the mining equipment, it's always like deferment of waste stripping and things like that gets in the way. And the mining operation is able to sustain that. But when you integrate in-pit crushing and conveying, you have to mine what's in front of you. You've got to move your benches sequentially. So the mine plan is more rigid, and you don't have the same level of flexibility. And everybody needs to understand that from the outset, that if you want to make the most out of IPCC, you've got to accept that you need better planning early in the stage of your study, and that you'll lose some flexibility. And that's just a given. It's very hard to avoid that. There are lots of other little things, but that's the key, I think.
And I think I guess the challenge is what keeps going. Keeps you going and looking at more of these, looking into the future, hopefully. So it's been great to hear your insights over these two podcasts. Really appreciate you giving your time for us.
pleasure. You've got to have some passion for IPCC if you want to. I mean, the industry needs change, and it's coming at us like an express train. And whether you call it climate change or the need to be more efficient in your operation, IPCC is one of the key opportunities for you to go down that road. So I think we need more experts as well. So I can retire then.
All right. Thanks very much, Phil. And so thanks for joining us today on Fresh Thinking by Snowden Optiro. You can get this on anywhere where you get your podcasts. It will also be available on YouTube. Please join us again for future episodes of Fresh Thinking. Thanks for your time.